All right.
Let's just save this question.
So
Actually,
let's get
it's
going.
super quick and it'll be on my mind if I don't ask you. Over here, why do I, this is not a table view, but for like the other part, this is search bar, right? So I'm trying to push it down by the height of this. So why, when I do negative 44, it works, when it's positive 44, it doesn't work? Because I remember I did the same thing once. No, never mind. Okay, got it. I was doing something completely different in the other project I referenced to. The other project is even out this one.
Okay.
Okay.
All right. So let's do. Let's talk today about testing. That's today's topic. I guess I'll go through some points and then we'll look at some code. So a lot of what I'm going to say is based off of the stuff that John Reed is doing. He is an iOS developer who sort of an advocate of iOS, of testing in iOS. I guess iOS has a bit of a checkered history with testing. It's pretty difficult to test in iOS because of the nature of view controllers. So maybe we'll talk a little bit about that after, but or as we go along. But there's been, I guess, maybe less of a strong testing culture in iOS development than there is perhaps in other platforms. But nevertheless, many of you will be working in places where testing is done. And if you're not working in such a place, you should look for a better job. So generally, it's something that you really should know, and it's a skill that is almost like relearning how to program, actually. So it takes a while to get good at it, but the more practice you get, obviously, the better you will get at it. So I'm just going to talk about like this at an introductory level, but hopefully you'll get enough information here to like at least start testing and go on and perhaps do, some more investigation on your own time. So basically, testing is only relevant for projects that are intended to live past initial ship date. Maybe that's true. Maybe it's not. I don't know. Because even to get a project to ship date, you might need to do at least some testing. So the thing is that we already do testing anyway when we're developing, right? So when we step through the code, when we go into the debugger and we're debugging, we're actually already testing. So we have to do this, right? We have to confirm. So you write some code, you log something out, you're testing to confirm that what you just did worked. So you run the simulator, you verify what you've done works. So you are already testing by virtue of being a developer. So testing as a discipline, though, kind of formalizes this. So this is more of an objective way of verifying the quality of the code. So I guess what is the problem with testing like the way that we're kind of doing it now, where we're just kind of running something in a simulator, we're perhaps stepping through the code like to try and understand the code, or we may be going into the debugger and just verifying that certain values are coming out. So what is the problem with that approach?
It works, but I guess with testing you can actually pinpoint the issue.
You could do that with the debugger stepping through the code too.
Is it because the debugger you can only do like very basic kind of tasks, like just get a value, you can't really see if a function works, really? Or like
I don't think that's really the reason. So think of it in terms of science. What is the nature of an experiment in science? So this is like it's kind of like we're setting up an experiment for the code, right? So what is the nature of a scientific experiment? Well, it's repeatable. That's the big trick, right? So if you say that you you boil water and it boils at this temperature at this altitude or whatever, that should be repeatable, right? So by writing out our tests formally, we allow any other developer to test our code. So notice, like, when you step through your code, that knowledge is gone, right? As soon as you step through your code or you go into the debugger, like, you're not recording that in any way. So another developer has no way of knowing that whether or not you've confirmed the code works, okay? And nobody can run those tests in the future. So what if your code works, but then you add a feature and you break something? Okay, so there's no way of verifying that you don't have regression bugs like that, right? So this is why you want to write tests. It provides a kind of formal way of testing the code. So the idea of testing code is another difference is that unit testing at least, these tests do not ship with the code, right? So if you could write some kind of verification stuff, like you could write asserts in your code, but the asserts in Swift are automatically removed at build time, at release or release builds, but not in Objective-C. Asserts are actually shipped with the code in Objective-C. You can remove them using macros, but generally you don't want to ship your testing code with the release build, right? So testing puts the test code in a completely separate area, and that's not even it's not even compiled with the final release build. So it's completely separate. So that's another advantage. Well, let's actually. Since we're talking about the advantages and disadvantages, I'll just jump to that section in the notes. I'm just going to talk about the advantages first. So one advantage is that we spend more time writing code rather than hanging out in the debugger. So we like writing code. We're programmers. It's more fun to write code to verify your program than it is to do it in the debugger. Okay, you can find bugs early in the development process. So the thing is that the longer a bug exists in the code, the harder it is to find and the more expensive it is to find it. Okay, so if you can catch bugs early in the development process, this is a big advantage. It provides living documentation, so another developer can look at the code and see what the intention of the programmer is, and the tests provide documentation. So, and the thing is that unlike other documentation, because that documentation is actually a part of the program that runs, if something is no longer the case, then the test won't pass. So how if you put like a comment or something in your code and then you go back and you change something and you don't update the comment, the comments can get out of step with the code. So comments in code are not as good as tests for documenting the code. It guides better code architecture. So the idea, and we'll look at this in more detail in a second, in order to test something, your code needs to be structured in a certain way. And this sort of helps to guide best practices. It allows you to make changes to your code with more confidence. So if you want to add a feature or make a change, you can always verify that you didn't break something in the process if you have good test coverage. It catches regression bugs in later versions, so it makes sure that you don't sort of break something going forward. And it forces you to reason pretty thoroughly about the code, because when you have to write tests against it, you kind of think more carefully about the code. You sleep better at night. That's a good one. Everyone wants to sleep better.
I want to sleep.
The cons are, well, you can see that one of the pros is that we write a lot more code, but the cons are that we write a lot more code. So some people think that this might take away from building exciting features. And certainly it's always more exciting to build a feature than it is to write test code. But I think a lot of the data on this shows that although there is an initial cost in terms of time and productivity, that in the long run, you actually end up spending around the same time, pretty close to the same time as if you didn't have any tests. But the advantage is that once you have tests, then you have much more reliable code base going forward. So if you do it incorrectly, it can actually hamper progress. So that's, I guess, why you want to make sure that if you're testing, you do it correctly. So another con is that you sleep worse at night. Okay, so let's.
Sleep better by testing. You sleep worse by testing.
You sleep worse by not testing. Okay, so there are many types of software tests, such as security tests, installation tests, accessibility tests. There's tons of different kinds of tests. So you can actually I'm linking here to a Wikipedia article, and you can see that they list 19 different kinds of tests. Right, so A/B testing, security testing, all this kind of thing, acceptance testing, regression testing.
Is there a way to test whether or not we have retained cycle?
Yes, we'll talk about that tomorrow. Actually, that's something that you, so there's like analyzer tools built in to Xcode that you usually do that with. So you're not really going to write like a unit test to verify that, I don't think, typically. But that may be part of like putting the app through an instrumentation process where you're testing its performance and you're testing for leaks. So that's a little bit different than what we're talking about in terms of unit tests, but that is a type of testing. And we'll talk about that tomorrow a little bit in the debugging section. So actually, software testing has its own discipline, sometimes called QA or quality assurance. But we're concerned about unit testing. So testing as a separate discipline might be somebody different who's testing the code than somebody who writes the code. So some sort of like acceptance testing, verification testing, that sort of thing might be a separate like person who actually does that kind of testing. Unit testing is usually done by the programmer because they have intimate knowledge of the code, and it makes more sense for them to actually be writing these unit tests. There's also interface testing, and there is an Xcode interface testing framework. I'm not going to talk about that today, but just for now, know it's there. So it allows you to automate like button taps and so on to verify certain things are working the way you expect. So unit testing tests small units of code, usually functions or methods. So these are like tests against individual functions or methods. And usually each function or method may have more than one test, typically. So you might want to test certain edge cases or test certain error conditions and make sure that the code works the way you expect. So unit tests are distinct from functional tests, which test larger chunks of code and how they function together. So for instance, in a functional test, you might hit the actual network. So unit tests, they need to be really fast. So you're not going to be hitting an actual network. If you're doing a network request, you would fake this network request and test your code and not test that actual network, right? So by isolating your code, you can actually test your code and you don't run into like problems where it's actually a network error when what you're really wanting to test is your code. So if you actually do want to test like your network and stuff and things like that, then those are kind of different tests that you wouldn't want to run together with your unit tests because you want these unit tests to be really quick. They should be part of like the build process. Each time you build, you should be building these unit tests. Okay, so like for example, let's say that you had an app that had a graph, and let's say that once that graph reached a certain value, that maybe it might change color, right? That you might verify that. You could verify that in some sort of unit test, but if you actually wanted to visually see it, you might build something like a functional test or some kind of UI test for something like that. Okay, so this is really just at the unit level. So it's like very small little tests. Okay, so there's also within unit testing, there is a discipline called TDD, or test-driven development. Has anyone heard of TDD? So TDD is a discipline of writing unit tests first. So you write tests before you write your code. So, and obviously, like, you write a small test that you begin by writing a small failing test, because obviously you haven't written the code yet, so the test would fail. And then what you do is you make that test pass, and then by writing the simplest code, and then you refactor, okay, and then you write another failing test and make that test pass, and refactor. So you do this repeatedly, this cycle. It's sometimes called red, green, refactor. Okay, so that's why you see the red in Xcode when you're running the tests. That's failing test. Green is for passing test. So refactor basically refers to refactoring the production code, but also refactoring the test code. So you want to make the test code readable as well. Okay, so that's 3 stages of test-driven development. This obviously takes a little bit more like practice to get in the habit of writing a test first. All right, we talked about this. So some beginning rules. So only ever test publicly exposed methods. So why is that? So when you start programming in Swift, so far we've just been doing Objective-C, but when you start programming in Swift, you'll notice, since you started in Objective-C, you'll notice a lot of people really don't understand the idea of a public, of sort of like public methods or properties. They just stick everything, by default, it's internal in Swift. And they just make everything internal, so everything is visible in that from anywhere in that module. This is going to be a problem, right? Because if you make a clear distinction between private and internal, public, or open, so then you will only test stuff that is not private. And why is that? Any ideas? So what's the nature of a private function? It's obviously it isn't. It's something that isn't. It isn't integral to interacting with that object, right? Because that object's private business. So if you tie your test to private methods or private members of an object, then you will make your test code a pain in the ass, right? Because now if you want to change something that's private, it will break your test, but there's no advantage really of testing private stuff, right? Because you should be able to get the same, you should be able to test that object by just testing whatever is public on it. So essentially, you're basically creating fragile tests for no advantage. So don't test, only ever test stuff that's available from the outside of that object. Do not test internal stuff. Never test Apple's code. Let Apple test Apple's code. They're having enough problems with that. So never test actual API calls, for example, or other types of things like that, like core data. Never actually save to core data in your tests. And why is that? Any ideas?
Will actually save core data.
Yes. And why is that a problem?
Because we don't want to save core data. Because it's a test, so we don't actually need whatever's saved.
Yeah, right. I guess we could always clear out the data after our test or something like that, right? But we don't actually want to in a unit test, we don't want to test core data for a number of reasons. One is that it's too slow for a really fast test. And secondly, we're going to be bound to Apple's code. So something might break because of Apple's code, so we're not really isolating our stuff. Okay? So we don't actually make real API calls. We don't save to real databases, that kind of thing in unit tests. So one of the things that you'll notice, and this relates to like how testing affects the discipline of coding, is that it'll be much easier to test classes that are simple. Okay, and so that will drive your design of classes to be simpler because they're much more testable. Similarly with functions. If you have a function that's doing 15 things, it's going to be very tough to test that thing, right? So if that function returns a value and then changes state, then that's going to be a complex test, right? Whereas if it just returns a value, that's easy to test. Or if it just changes state, that's easy to test. So when your code becomes difficult to test, you realize that you need to refactor your code in order to, well, if you're writing tests first, then that probably isn't going to happen. So that's one of the reasons why testing first is an advantage, right? Because it drives the design of the code. Whereas if you test after the fact, then you're going to be like refactoring the code to make it easier to test. So that's an extra step, right, of refactoring. So there's the 3 A's of unit testing, which is arrange, act, and assert. Okay, and I actually got them in 3 comments, so you can just paste them into a unit test to start your unit test with that. So arrange is that you arrange some object. So you instantiate an object, let's say, for example, right, like init an object. And then you do something to that object. Let's say you call function. Okay, that's acting. And then you make some assertion against the result of that action. Okay, so you're asserting that something is the case. So you can assert that like nil is the case, or true is the case, or false is the case. Any of these, we'll look at asserts in one sec when we look at some examples.
Wait, so arrange, act, assert. So arrange is the actual code of it. Test or
arrange is like, so you need to get your code ready to do something, right? So like, let's say you need to initialize an object, right? But if you don't need to initialize an object, let's say that you have a class method, then you could skip the arrange part. So you don't always need to arrange, it depends, but normally this is the normal process.
And act is the actual function, actual test code.
Like executing the function.
And assert is just the final, like, true, false, or...
Yeah, so you're saying, like, you're trying to verify something in the assert statement. Okay, so you're saying, like, did person get set to Fred in the assert? Or let's say that it were a function that we're doing some math, you might send it some values and assert against the answer that it should be returning the correct answer. Or let's say that you were sorting some list or something, you might feed it some data and expect a certain result, and you would make an assertion to confirm that that result was attained. Okay? So you're always like asserting something to be the case. I assert that this is the case, and if it fails, it'll be a failing test. So there's 3 types of unit tests. And this is sort of like, John Reed is actually taking this from some other books, and I have some links below. You can, like, I'm not going to link to all the books and everything. You can follow up on his website or his videos or whatever. I'm not going to link to those. It's not really important, but he simplifies it down to these 3 types of tests. I think it's really useful a way to talk about this. So basically we have a return value. So this is where you call a function and it returns a value, and you just compare it, the return value, to an expected value. So this is super simple. You have your test, you call a method, on SUT is the system under test, and it returns a value, and you make an assertion in the test against that return value. Okay, so you have already been doing this. You did this in Warcraft, right? Where you called a method, you expect a return value. So the next one is state test. This is where you call a function that causes a side effect, like a property changes a value. Let's say you call a function and that function does something and then changes the value on the object. So this is a state change. And then what you can do is you can query the object to see if the change state matches your expectations. Okay, so notice that we don't have a return value and state change test. Right. So if you're returning a value, don't change the state in the same function. Okay, so here's the state. Here's the diagram for the state test. So we call a method. It changes some value on the system under test, and then the test queries the system under test for that state change. So those 2 are very, very simple. You should be able to start writing unit tests like this right away, right? They're very easy to write these tests. Okay, any questions about these 2 test types? So really all the action in testing. So these 2 things are really super simple and super easy to grasp. And all of the confusion and the difficulty of testing comes in to this 3rd type of test, which is called the interaction test. So here, like you can see, oh, it doesn't quite fit. Let me make it a bit smaller. Okay, so interaction tests. So here your test calls a method, and that method calls something else. So you see that your test calls the system under test. System under test calls some dependency, right? So this is the nature of the interaction test. So we want to be able to test this thing. So for example, you have a person manager and it has save user method that saves the past in person to user defaults. So here we have a dependency on user defaults. User defaults is going to make a save, and then somehow we need to test whether that save happened the way we want. Okay, so we don't want to use an actual user defaults to test this. So I think I've already explained why not. We want the test to be fast. We don't want to be actually testing Apple's code. We want to just isolate our own code. So we have a dependency that we need to deal with here, right? Does everyone understand what I mean when I say dependency? Not fully. So if your object depends on some other object to do some work, right? Then that's a dependency. So like user defaults. Like you want to do something with user defaults, that's a dependency your object has. So if your object is calling user defaults, it's dependent on user defaults. But if it is, let's say, calling a manager object that is going to be dependent on user defaults, then your object's dependent on the manager. And the manager is dependent on user defaults, right? So that obviously makes our tests a little bit trickier here, right? Because we need to figure out how to test when we have a dependency. So that's what the interaction test type is all about. So we'll come back to this. Well, actually, why don't we let's just keep going with the interaction test, and we'll come back to this demo in 1 sec. So interaction tests and dependency injections. So one of the things about these dependencies is that we want to be able to inject these dependencies, and so that's basically a fancy word for meaning that we want to pass the dependency in from outside the object rather than initialize that dependency internal to the object. Okay? So the reason that we need to do that is because then we have control over this dependent object, right? We can send in whatever object we want so that we can control the test, right? If we're internally initializing this object, we're frozen there, right? With whatever that thing internally initializes. So like, think of it like this. Imagine the difference between you, let's say, growing your own food. Let's say that you have a rooftop garden, okay, and you grow your own food, versus having food delivered to your door, right? Which of these arrangements is more flexible? Delivery, right? Because you could have somebody else grow the food and deliver that. Or maybe maybe you might have, like, I don't know, somebody attend to your garden and deliver the food. Or they might deliver it from Amazon or deliver it from Walmart or wherever. I'm not endorsing any of these delivery services.
Steve got paid. Rather than like a Mike somewhere to make sure Steve's actually endorsing them.
Okay, so that you can see how much more flexible that is. We could fake a delivery, right, to the door with this arrangement. But if we're growing our vegetables, we're stuck with whatever is there, right, with the cabbage or whatever we grew. So this is the difference between, injecting this dependency versus internally creating this dependency. Okay, so there's basically 2 types of interaction tests that we're going to talk about. But before we talk about that, we need to talk about the different ways that you can inject an object, a dependency. So we usually want to inject these dependencies as fakes, not real ones. So we want to make sure we inject these dependencies rather than new them up internally. So for example, user defaults, we want to be dependent on user defaults. We don't want the real user defaults. We want a fake user defaults so that we're not testing Apple's code. We're isolating our own code. And that's what we mean by unit test. So a functional test might actually try to really save to user defaults and verify that by looking in the app sandbox. Like that, yeah. Is that good?
Sorry, I blanked on that.
Okay, so all right. So here we have a, you notice that we have a person manager and we have user defaults and we have an initializer that initializes user defaults standard. So this is the Swift way of doing it as user defaults, standard user defaults. Okay, so this is wrong. We don't want to be dependent on user defaults by initializing it internally. So in Swift, I could just do actually user defaults.standard outside of the init. Same thing though. Okay, so this is the right way to do it. Notice how the initializer passes user defaults in and then sets it. Okay, so this is called constructor injection, where we're passing the dependency in through the constructor. So I'll talk about this in just 1 second. I just wanted to make sure that you understood the difference between initializing the object internally versus passing it in as a dependency. Okay, so that's just like a generic way of trying to show that. So right away, though, you see a problem here. I'm passing user defaults in. So, so if I wanted to pass a fake object in, how would I do that here? So it would be of type user defaults because I've declared the user default. So we can ask a question about whether that's the best way to do it or not in a second. But if I wanted to pass a user defaults object in here, how would I do that? Where it was like a fake object.
You make an optional and just throw in a nil.
Optional
user defaults object. Then set it to nil and throw it in.
So how's that going to help me pass a fake object?
Is a nil it's fake?
Well, that would be a non-object. I wouldn't be able to do anything with it. So how would I pass in? How would I create my own user defaults and pass it in here?
Subclass.
Yes, I would subclass it. I could make some change to it, and then I could pass it in here because it is at least this type. But that's not really going to solve my problem, though, right? Because internally, I would have to know, let's say that, for example, I added a property to user defaults called count to track how many times this thing was initialized, let's say, right? If I pass in my, let's say I call it mock user defaults, that is a subclass of user defaults, and I pass it in through this initializer here, am I going to be able to access count? No, right? Because count is on the subclass, and I'm casting it to user defaults, which is a superclass. So that count value would not be accessible here. So how do I solve that? I'll let you think about that. So can we solve this with protocols? So answer is yes, we can. So we create a protocol, and what we can do is we can extend user defaults to conform to that protocol. Okay, and then what we can do is create our own object that implements that protocol. Bam, we can interact, we can intercept calls to it that way, and pass and make this rather than user defaults. We just make it like user defaults protocol, our custom protocol. So I'll show you how to do that in a minute. So there's 4 ways of doing dependency injection. Okay, I'll just go through this, and then we will, and then maybe we'll look at some code. So there's extract and override. There is method injection, property injection, and constructor injection. So we already talked about constructor injection. So this is pretty simple. We just pass the dependency in through the initializer, right? And I just talked about why user defaults is probably not going to work here. But this allows me to pass a dependency in that's a fake object that I control. So then I can, test against stuff. Okay, so that's constructor injection. You should prefer constructor injection because it makes the dependencies more explicit right from initialization. You make those really explicit. So if you have, so let's go to the top. So this is extract and override. So here you can see that this is, the save method is dependent on data. And right, so you can see that here I'm initializing data, user defaults.standard. Okay, so I'm dependent on user defaults. Calling defaults.setValue person for key person key. So that's the wrong way to do it because I've got that dependency inside this save method. So here is extract and override. Basically, you can see that I've turned that defaults property right here. It was a property, see? Or was this property? Here, I've turned it into a method. You can see that returns user defaults.standard. So this allows me to subclass and override, right? So I can subclass person manager and override defaults. You can see that I've got return something question mark here because we still have that problem with user defaults, right? Because I'm supposed to return a user defaults object. So if I want to return a fake one, I've still got that problem that I was talking about with the protocols earlier. Okay, does everyone understand this extract and override? So basically this allows me to, the advantage here is that I never needed to change the signature of save because I just created this private method. Well, actually, sorry, it's not private, this is public. That's why I'm able to override it, or internal. So it's just a method that is called defaults that returns user defaults. So this is just turning that dependency into a method that I can then override, and then I can control it. I can return something else in my override. Okay, so method injection. So this is, here we have that method again, right? We can see that this time we're passing user defaults in through the method. Okay, so you see that we save with defaults, user defaults. So then I can just call defaults set value. So I'm able to pass defaults in. Now the problem here is that you need to be able to change the signature of save. So if you are able to do that, if like you have a lot of dependencies on save, then this might break a lot of things. So that might not be possible in some applications. So that's why you would have to resort to this extract and override if you cannot change the method signature. So property injection. So here we just have a property defaults, and then I'm accessing defaults. So I would, like, this allows me when I create a manager object, I can just set this property with something my own user defaults. Okay, and then there's constructor injection. All right, so we'll come back to stubs versus mocks in one sec. Let's go to look at, where was that demo stuff? Or was it?
Right below the 3 names.
Oh, right. Okay, so return value and state. So let's just do these two, and then we'll come back to. So if you want to just clone down the project. All right. So let's look at and see what we have here. As you can see that I just have one view controller with nothing in it. We're not really using the view controller here. So we have a person object, my trusty person object. I'm subclassing NS object here. And the reason is that I'm using NS coding because I want to be able to convert this object to a plist, or sorry, convert this object, I want to serialize this object to an NS data object because I want to save it to user defaults. So I can't save a person to user defaults because the system doesn't know how to serialize that object. So I need to tell it how to serialize it with NS coding. So this is a little bit of a review. So you can see that I have encode, and I also have encode with coder and a knit with coder. Okay, so just a few things here about Swift. We'll be talking about these things in more detail, but you can see here that I actually have a struct inside this class, okay? And it's just called key, and it has these static let first name with the string first name key, right? So this is automatically, you can see that the compiler knows that, can infer that this is of type string. So static just means that it is an object member, or it's a member of the struct. It's not a member of an instance of the struct. So it's like class. So this allows me to do like key.firstname, key.lastname instead of putting raw strings in here. So you can also do this with enums. Okay, so anyway, in code, I'm just encoding self.firstname for that key, firstname key, and self.lastname for lastname key. And then in the initializer, here you can see that I'm decoding. So this is if I want to call init with coder. So if I have an NSKeyed unarchiver, the unarchiver would be calling this method here. So otherwise, this method does not get called. Normally, I wouldn't call init with coder myself. I'm not going to call init with coder myself, right? This is called by the system when the NSKeyed unarchiver gets called against this object. But because I am an NSCoding object, I must conform to this. So you can see that I'm just doing a decoder decode object for key, and then that's the first name key here. And then this will return a type any question mark. So that is an optional any, so it could be nil. So you can see that I'm casting it to an optional string. So this, we'll talk a little bit more about this another day, but you can see that actually here in self.init, I'm calling first name, last name, so I'm basically calling the initializer of the object, which is right here. And I'm passing in the whatever we get from first name. But if first name, so this double question mark here says that if first name is nil, then use this value. So it attempts to unwrap it. And if it unwraps it, it'll use that value here as an unwrapped value. Otherwise, it'll just use the empty quotes. So we'll talk about this another day, okay? Okay, so this is init, and we have properties, first name, last name, and we have full name here, and this is a computed property. Okay, so you can just think of this as like in Objective-C, how our properties were in Objective-C, where we had a getter and a setter. So this is the getter. So when we call the getter on this thing, we're going to return first name and last name as a string. So you can see that computes it based on what first name and last name is. Okay, so that way I don't need to like create a full name and like set this somewhere, right? It just gets set when I call it. Okay, so I also have a bills object. You can see that obviously this is an internal dependency here.
Actually,
yeah.
Wait, would you say the point of this get was? Why can't you just have return first name, last name?
Well, you can in this case because this get thing is optional when you don't have a setter. But why am I making this a computed property?
No. I was just wondering why there was a get. It had to be get.
There doesn't have to be in this case because I don't have a setter. So, but I'm putting it there just to be explicit that this is a computed property full name. Okay, so I have this other dependency, never mind here, because we've been talking about injection here. So you can see that I am dependent on Bill, but this is just a property that is an empty array that takes bills. Okay, so this is one way that you can initialize this. You can also initialize it like this by calling Bill like that, and then with the empty braces. So that's also a possible way of initializing it. There's two different ways. So you can see that I have this pay bill method. It takes a bill and it just appends to the bill's property. And I also have this property here, total owing. We'll get to this when we look at, this is also going to be used for the state test. And this is going to be used for the stub. So we have a total owing, which is a double, and it calls total owing, passes in the bill, and passes in this other object, bill computer. Okay, and essentially build computer is going to compute the value and return it. So in this case, like we're just kind of faking out the idea that maybe this is calling a service or something and doing this computation. So that's why we have an external object handling this. Okay, so person manager simply has a save method, and it takes a data object, so that is a person that has been serialized, and a user defaults. And it calls defaults, set person for key, person key. So it's going to save the person using user defaults. So that's the person manager is a very simple object, not doing much. Okay, so for these first two tasks, we're not going to be looking at this yet, but I'm just going to step through the code anyway. So you can see here is where we're doing some interesting stuff. You can see that we have user defaults protocol. So I've created a protocol for user defaults, and this is how I'm going to be able to create my own fake user defaults object. You can see that I am extending user defaults with the user defaults protocol, and the thing is that set value for key is actually a method that user defaults already implements. Okay, so I'm extending it. I'm extending user defaults, saying that it conforms to user defaults protocol, but it already does. Okay, does that make sense? User defaults already implements this method. So why am I doing this? Why am I defining a protocol that user defaults already implements? Because this allows me to create another object, right? My own fake user defaults object, and override these, implement my own set value for key or data for key. Okay? When I create my own custom one, and I say it implements user defaults protocol, I have control over these two methods. And that way I can pass this dependency in. I can say that the dependency is not a user defaults object, but a user defaults protocol object. And then I can pass either a user defaults, because that conforms to user defaults protocol, or I can pass in my own custom one. Okay, does everyone understand that? You don't.
Yeah, I get it, but I probably won't be able to use it.
Right, so I'm trying to, basically I'm trying to create a fake object, right? That, because I don't want to actually call save on user defaults, but I want to know when save has been called so that I can like intercept that call. And the way that I do it is by creating a protocol that user defaults already implements, right? Because it implements these two method signatures. I got it from user defaults, right? I got these two method signatures from user defaults. That's how I got the methods. That's how I got the method signatures, right? So if I extend user defaults with that protocol, user defaults already implements it. So if I have a method with a user defaults protocol parameter, I can pass in this extended user defaults object instance, right? I could make a user defaults.standard, cast it to a user defaults protocol, and pass it in. Right? And it already implements the set value for key and data for key. It already implements it. So now if I create my own custom one, then I completely control these two methods. I can do whatever I want. So if we call set value for key and I want to inspect the value, I can intercept it, inspect the value, and do tests against that. Okay, so build computer, you can see is just, it says compute. It just passes in an array of bills, and it actually calls this faked, like some sort of network call or something, do some network request with the bills, okay? And this is essentially just adding up all the values and returning them. Okay, so the bill object is simple. It just has an amount value, and that's it. Okay, so let's look at, we'll look at this mock user defaults in a sec because we're not there yet. So let's look at the person tests. Let's see. It seems to be having some sort of build error. I don't know. That's not a real error. Or is it? Oh, I seem to have missing a bracket.
Where?
It's right at the end of this test case, this test file. Okay, so let's look at let's look at the person tests. So what we want to do is open up the person object. If you option click on person object, then we can open it in this side panel here. Okay, so I want to know if person init was called once. So I want to initialize person, and I want to know if person was called once. Okay, so how would I go about testing this? Actually, let's do first name first because it's a little bit easier. So what do I do for a range here? So I want to test to see if I set first name, if it actually does succeed in setting the first name.
Check if there's a first name.
How do I go about arranging this? So notice something here in this initializer. Like this is a let here, first name, right? But it's not an optional. And the reason is because Swift allows us to, as long as everything is set by the end of initialization, it does not need to be an optional. So we're not allowed, everything has to have a value by the end of initialization. So if something does not have a value, then we would need to make it an optional so that it could be nil or set some default value. Does everyone get what I just said? Yeah? Okay. So that's why this can be a let here, because once it's set, it's not changeable, right? We can't set it to something else. Okay, so what do we have to do here? I need to arrange, so I need to do what? Any ideas? Well, so how do I do that?
We don't know how to code Swift.
What's that?
We don't know how to code Swift.
You don't need to know how to code Swift. Sorry. What's your dog's name? What's your dog's name?
Latte.
Latte.
Oh,
Latte.
will
Oh. Latte.
Once again, let me look my free class again.
So how do I arrange this? What do I do?
If person dot first name is not equal nil.
Person dot. Like that?
Yes. Wait, no.
So it says use of unresolved identifier person.
Oh, we haven't instantiated, so we first instantiate people.
Okay, thank you.
Oh, that's arrange.
Arrange. So first thing is let's make a person. So we can call the system under test because it's the system that we are testing. So person, and we can see that we have an initializer here. And we wanted to test to see if first name gets set correctly, right? So let's make the first name Fred. And we don't need anything for the last name because we're not testing that. So next we want to do, so we can't, let's see if that works. I don't think it's going to work. No, because, oh, it's system under test. So this is still not going to work because first name cannot be null, right? It's not an optional. First name is not an optional, so we cannot check to see if it's null because it cannot be null. Right. So what do we want to do here? So first name is set. So Actually, arrange and act are the same here in this case, right? Because this should succeed in also acting on the object, which is setting first name. So what do we do for assert?
We do like set first name equals Fred.
Right. So if we do xet assert true, well, we can do xet assert equal, and you can see that there's all these different ones here. If we do equal with expression, so expression 1 is, so usually what we're going to do here is we're going to do like something like expected equals Fred. So if we do SUT, act is the same as arrange in this case because the person initializer is setting that value for us. Okay, so that's our first test. So let's see, what is the problem here? So this should be person dot first name, right? Okay, you see how the simulator came up for a sec because it's actually building the app. So our first test passed. Okay, so let's do the full name. So what do we have to do?
So the person given full name, first name and last name.
Right. Okay, so we'll just copy this. Let's just copy this part. So this is going to be, let's set the last name to something. Okay, and in this case, we do have an act, right? Because we have that computed property full name. So let full name equal SUT dot full name. Okay, so now we are going to do an XUT assert equals. And we need an expected, so let's just do let. Expected equals full name. Save that out. All right, so we're making headway. So we've got 2 passing tests. So let's just, how about let's make sure that person init is only called once. How would we do this? Can we just use the person object to do this? So we need to get a count, right? And we need to have a count variable that gets incremented every time a init gets called, right? So that's what we're going to need. So can we do that with, so how do we do that with the person object?
You create a property on the person called like count or something, and then every time it's knitted, just increment the property of count.
Right. So so yes, that's true. But what would be the problem with that?
Oh, every person will have a count of 1.
Well, if hopefully it only has a count of 1. But if for some reason it got initialized twice, we would find out about that. But what's the problem with us changing person and adding a count variable to person? This is a very important idea. Our tests are starting to change our code, right? Our tests are bleeding into the code. That's really bad. We don't want the person having a count variable on it that gets set in initialization. We don't want the person object to have that. We only want the person object to have that for the purposes of testing it. Okay, is that clear? So how do we do that?
Can we override init inside the test?
Yes, that's right. So we're going to create a fake person that subclasses person, and we're going to have override init with first name, last name, and then we are going to have a variable called count, start with 0, and then every time init gets set, we're going to do count plus equals 1. So we also need to call super.init. Super.init. So we'll just pass in first name, last name. Okay, so we need to call the supers init there. So that's notice how we're able to set that right up inside the function there, right? We can embed that fake class right in the function. So if we wanted to reuse this fake person elsewhere, then obviously we need to move it out of the function because no other function is going to be able to see this object. Okay, so so that is the setup. So we still need to do something else for the setup. What do we need to do?
Create a person.
Yep. So we'll call this system under test, and this is going to be the fake person. And we'll just pass in an empty string there because we're not testing the string. So what do we need to do next? So this is actually I guess this is part of act and arrange are the same in this case. So what next?
Is expected going to be 1?
Oh, right. So we need the expected. So let's set expected to 0. We actually know it should be 1. Just so that we have a failing test, and then we'll actually see how that works. So xet assert. So let's see. Oh, right. So we need this expected, and we also need the, I guess, maybe act could be sut.count. So let's do count or expected is equal to count. So, sorry?
When we set dot count?
That's what we have there. Yeah.
Oh,
So system under test is the fake person. So let's just run that. So that should fail. Okay. So you see how that fails. Now, one thing is you notice how my my test stops execution here, and it make that little sound. So if you want to adjust the way that Xcode functions when you like build or run or whatever, you can explore this behaviors tab here. So you can see that in my case. Let's see, testing is right here, this section. Okay, so when the test fails, you can see that it's playing this func sound and navigates to that first issue. Anyway, so you can play around with those, just showing you that that exists. Okay, so if we click on this, we can see that 0 is not equal to 1. We expected that, so we're going to just run that again. Okay, so that is some basic tests there, testing when we initialize that we're only initializing it once by overriding the object and creating a fake and overriding an it. And then we're calling also first name and confirming that the first name property got set and the full name function works as we expect. So in this case, like, you know, it might not have had the space or something. There might have been some problem here. Okay, so those are basically return value tests. So now next we're going to do some state tests. Okay, so we want to do initialize Bill and make sure it only gets called once. So let's pull up Bill. So go to Bill, and if you hold down Option, Enter, you can see that Bill is right here. So we see that Bill does have an initializer with amount. So how do we go about confirming that bill when we initialize it only gets called, the initializer only gets called once?
Same as before.
Okay, and what was that?
We override. We create a new class.
Okay, so subclass. We'll call this just fake bill, and it's going to subclass bill. Okay, and we're going to override init with amount. Right, so we are going to call super and just pass in the amount. And once again, var count equals 0. And count equals 1. So arrange let system under test equals bill with an amount. Just set that to 0.
When do you fake bill?
Hmm?
Fake bill?
Oh, right. Sorry. Thank you. Fake bill. Yes. Okay, so act is going to be count equals sut dot count and expected. So I'll set it to 0. And just run that test. Okay, so change the value to 1. Run it again. Okay, so the next one is going to be, so this is going to be on the person object. So notice that person has a pay bill method, so we're going to test this function. So we want to see if, so this is just going to be a simple test to see that when we pay a bill, or when we call pay bill, that bill is actually appended to this array. Okay, so so what do we need to do to arrange?
Create a bill actually appended.
Okay, so create a person first. So that's going to be the SUT, right? Person. And we are going to pass in nothing for the name. And we also need a bill. So with an amount, so let's just put 20 in there. Okay, so we need to act. So here we are doing the SUT dot pay bill. I'm just going to pass that bill in there. And now we need to do an assert. So we can do XCT. Well, let's do let expected. Put this up here in the setup. So let expected equal 0. Okay, so that's going to be the count. Okay, so XCT assert equal expected equals SUT dot bills dot count. So actually I should probably, I think that's fine, yeah. So that's, oops, another mistake here. Okay, so I'm just running this test now. That should fail. So that fails, so let's just run that again. Okay, so now I could obviously verify this, you know, the bill amount or whatever additional stuff. But this is an example of where a function or method changes state on the object, right? So we call pay bill and it changes the state of the bill's property. So you notice how the test is calling this function and then it calls again into the object to inspect the state, right? So that's a state test. So those are the two really basic tests, which is the state test and the return value test. So those are really simple and you should be doing these kinds of tests right now. There's no reason to not do them. Okay, so let's go back to interaction tests. So this is where things get interesting. Should we take a 5 minute? Yeah. Yes. Okay, so let's finish what we're doing. Actually, while we were taking a break, I noticed there was a mistake in the notes here, so I did a fast update and pushed it up.
Refresh it.
Yeah. So, okay, so stubs versus mocks. So this is really where kind of like all the complexity in unit testing comes in. So you know, the state test and the return test, like those are very easy kinds of tests. And the stubs and mocks are where things get a bit more interesting. So we usually, as I already said, we usually don't want to inject an actual object, an actual dependency into our objects. We usually want to inject some kind of fake object. So there are basically two fundamental types of fake objects, and this is coming from John Reed, and Reed has gotten this from other guys on this topic. So this is really simplifies the mocks and stubs. Sometimes people make it really complicated, and so there's just really two types, and so that keeps it super simple. And these are stubs and mocks. So the difference has to do with what object the test queries. So it has to do with who the test is querying. So if the test is querying the fake object, and this is called the stub. So if it's asking, if it's asking the system under test for some value, then it's a stub object. And if it's asking the fake object, if the test is querying the fake object, then that's a mock. Okay, so this is showing here in a diagram. Let me shrink it down a bit. So this is the stub. So the stub calls a method on system under test. System under test calls something on the dependency. So we're calling it a stub here because this is some sort of a fake object. And then this thing changes some state or returns a value to the SUT. And then the test asks the SUT for that new value. So the test is asking the SUT. It doesn't ask the stub any questions. The mock, on the other hand, is calling the SUT. The SUT calls the mock dependency, right? And then the test queries the mock object. So that's the main difference there. So just a couple of notes before we look at the code. Well, just really one note, and that is that in Swift, you have to do this @testable import and then the name of the target. So you have to add this to the top of each test file. And that will allow you to essentially call methods that are not declared as public or open. So public basically means that it can be seen from other modules, and open means that it can be seen from other modules and overridden. Public cannot be overridden, just be seen but not overridden. Anyway, before they added this @testable thing, you used to have to declare everything public that you wanted to test, which was annoying because that means that you might not want your stuff public. You might want it internal, right? Okay, so in Swift there's private. There used to be file private. They've gotten rid of that. So there's private. There is public, open, and internal. So those four. Internal just means it can be seen anywhere in the module, right? So by default, things are internal. It's considered best practice to declare internal. I declare it internal because that means that you have thought about its visibility and you've declared it explicitly internal. A lot of people will just start writing and not even think about visibility. So if you,
What's private then? Private's just
it can't be seen from outside of the object. So it's like in
Internal.
Objective-C, just declaring it inside the .m file.
Oh, I see. So like in this kind of like security, almost be private, then internal, then public, then open.
Public,
in
yeah,
this
that's the.
Like in the sense of like openness, right?
Well, open just means that you can override stuff, right, or subclass or whatever. There's also you can also declare classes as final, which means they cannot be overridden. Okay, so that's just a little bit about visibility in Swift. Anyway, they used to have this thing, file private, so you may see file private in places, but that was Swift 3. And Swift 4 did away with file private. Anyway, there's some links there. The thing is like if you want to get some practice doing test-driven development, testing first, there are these code katas. There's like this bowling game code kata that most developers practice with. And so I've got a link to that there if you want to work on that at some point. So yeah, so let's come with an example of a stub and a mock. So let's go back to the code. And let's look at, so we did person test, so person manager test. Let's just look at this for a sec. So this is where I'm going to make my mock user defaults. So we can make sure mock user defaults is only created once. So this would probably be a good exercise. So range act. Sorry, so much. Okay, so range act and assert. So I think we didn't look at the mock user defaults object, right? So let's look at this mock user defaults object. So I've just declared this object inside the test target because it's a mock object. The production code doesn't need to know about this object. It's just for testing. So it only gets added to the test target. Okay, so you can see that it does actually import unit tests here, which is the main module of the app. And that's because I need the user defaults protocol, which is declared here in the main target. Okay, so that's why I'm importing it. So you can see that mock user defaults conforms to user defaults protocol, which is what we expect. So we can see that we actually have implemented the two methods, set value for key and value and data for key. So we've implemented these methods, and these are the same methods that user defaults implements. We don't know what user defaults implementation is though, right? Because that's Apple's code. We don't know what that is. But we are overriding these methods here so that we can write tests against this user defaults object. So you can see how this opens up like a lot of possibilities in terms of what you can do. So you can see that we've declared property values here that just is a dictionary. So this is how you create an empty dictionary of type string data. So here, set value for key, right? I'm passing in, notice that I'm passing in value, casting it as a data object. Otherwise, I'm returning here. So this is just a guard. We'll talk about this later, but anyway, it binds to this optional value to the value results if there is one. If there isn't one, then it just returns. So if there is one, then it's going to set this value here to whatever the key is and this data value that gets passed in, right? So it's just setting values. So if set value for key gets called, it's going to call this thing and add it to the dictionary with the key. Okay, is that clear? So that way, obviously, if I call set value for key, I can inspect the values property. This is like, because this object conforms to the protocol, it implements these two methods, but whatever else it does is my business, right? That's the advantage of this protocol and conforming to the protocol is that I can add whatever extra code I need. So if I want to run tests, I can inspect like the values property, right? To see if like what I passed in got set the way I thought it was going to get set. And data here you can see for a key, it's going to return, this returns an optional data object, and it's going to ask values, pass it the key. So again, I can test to see like what happens if this thing doesn't get set. What happens if I ask it for this key and it's not there? How am I handling that in my code? Okay, so that's the mock defaults object. So let's see. In the person manager here, I want to, it says that create test to see if mock user defaults is only created once. So we've done this already. So in this case, you can see that because I'm in control of the mock user defaults object, you can see that I've actually overridden a net here, right? So that I can see how many times a net is called. So I'm, in this case, using a static to track that. So let SUT equals mock user defaults, and that only has a net. So let's say let expected equals 0. So we'll just set it to that for now. So act is let count equals SUT dot, I think I called it something else, times, what is it? Oh, so this is mock user defaults dot times initialized. Okay, so XUT assert equals, so expected equals count. So that should fail. Oh, I don't actually need, I don't need the mock object. Yeah, I don't actually need this object in arrange. So that's, let me just run that again. So it should fail though for the reason that expected is 1, or count is 1. Oh, so that's, no, I had to, I'm sorry. I have to call this, but because I'm not using it, have to do it like that because I'm not using it. So I am calling the initializer there, calling the initializer, but I'm not using the object, so I just need to do it like that. So that should fail, and it does. And let's see the error. So it says that 0 is not equal to 1, which is what we expect. So if we make that 1 and we run it, okay, so you can see that mock user defaults, this is a static. So that's why we call the initializer and then we inspect the class to see if the class value got set, and it did get set.
So the var, this times is initialized is a class property.
Mm-hmm.
And by putting static, what does that do for it? What are you saying?
Well, there's static and there's also class.
Mm-hmm.
So static just means that it is a member of the class. So it's a class member, not an instance member.
I see.
So when I call the initializer, I'm setting the class member to increment by 1.
Okay.
So I'm just showing you that you can do this kind of thing. Okay, so here is test save user defaults using a mock. Okay, so we now know we can create this mock. So we're going to inspect this values object. So let's go look at the person object. Remember, sorry, it was person manager. Okay, so person manager has a save person with defaults. Okay, so we need to arrange. So what things do we need to arrange here? So let's look at the function. So is this function, is this method an instance member or a class member? Well, we know it's an instance member, right? Because it's not marked as static or class here. So it is an instance member. So therefore, we need an instance person manager.
So it can be either static or a class. Mark it as a class member.
Yeah. So if I could mark this as class or static.
Is there a difference between the two?
There is. Is it? I think it has to do with overriding. I think class can be overridden, static can't. You might need to look that up. I don't know. And they're always changing.
That makes sense. I remember static was like you can't change it or something in other.
In Objective-C, static is a whole different thing.
Yeah.
Like it doesn't mean the same thing as in Swift. So yeah. Okay, so save. So we need an instance of person manager. So that's the first thing. So that will be the system under test. So person manager. So what else do we need? So if we look at the method in question, we can see that it has two dependencies there. So what's the first dependency?
Person and defaults.
Is a person, that's correct, but what is the type?
Data.
Data, why is that? Why is the person marked as a data object here? What are we doing with person?
Oh, we're storing things. So
We're storing person in user defaults, right? We cannot store a person object in user defaults. We have to convert it to a data object. That's same as NS data. Okay, so we have to serialize person, pass person in. So that's another thing that we have to do in our range. So let's do that. We could call it data. So let's first of all set up a person, let person equal. So we'll just do person, and let's just call that initializer there. So we got to create one of these first. We don't need the names, that's fine. So we need to do let data equals ns keyed archiver. We need to do archive data with root object. That'll be a good one. And that's going to be, we can pass in the person. Okay, so that is now, if we inspect that, we see that that is an NS data object right there. So that NS keyed archive data with root object is able to make that data. So now we have the data. So we have this first parameter. Okay, so what about the second parameter? So something about this second parameter, notice it has two names. This is the external name, and this is the internal name. So from externally, we are going to call, so when we call sut.save, notice that it says person colon data with colon user defaults. So defaults is the name that applies internally, right? So we're using defaults here to refer to the passed in value. Externally, we use the word with. Okay, so what other dependency do we have in this method? User defaults. So is this going to work with user defaults? No, it is not, right? We cannot pass our mock user defaults object into this method because it is dependent on user defaults, and Apple controls that object. We don't control it. So we need to change this to user defaults protocol. Okay, so let's make a mock defaults object. So we need to do mock user defaults, and that doesn't have anything, that doesn't take any parameters. Okay, so now we're in good shape. So now we have everything we need. So that is, notice how a range was quite complex there. So now we need to act. So this is where we call the dot save method, pass in data, and pass in mock user defaults. All right, so that is, so Swift doesn't like this because this needs to be passed to a user defaults protocol object. Let's see what's the problem here. Always succeeds. Oh, I see. What's the problem here? Let's see. Kind of convert type value of type user defaults protocol to expected argument user defaults. So obviously that's a mistake. The compiler's wrong there, right? Because we changed that value, so it should know about this. Can convert user defaults protocol to expected. We changed that over here, so maybe it needs us to build it. Okay, both succeeded. Let's try running this. Still complaining, but then the test succeeded. Okay, so that's act, but we need to now we need to.
Nothing.
Well, I did cast it to this, but it should know it's that. Anyways, let me try running that again. It should actually know it's that. Yeah, it's fine. You don't need to cast it. So we need to do assert. So we have acted, we have arranged, we have acted, and now this is a mock, right? So notice we are asking the mock object for changes to itself. Not asking the SUT to see if there was anything changed. Okay, so that means that we're asking the mock user defaults object. So let's pull up mock user defaults and put it over here. Okay, so we called save, and let's just see if we go back for a sec. Save called set person for key person key, right? That's what the defaults method, it called whoever got passed into default, which was our mock object, the set person for key, and it was person key. So here we go here. So here is the object. You see that we called this method, and basically we added it to this values array with the person key. So we could, the first thing we could do is just assert, xct assert equal. So let's say that let expected equals 0. So let's say the let's get the count on mock defaults dot values dot count, and let's see that that is the expected value. Okay. So let's run that. Okay, so we expected it would be 1 anyway, so we'll change that to 1. Okay, so that passes. So now we might want to say, we may want to get this object back out and try to unarchive it or something like that. Obviously, like this keyed archiving thing, this is also a dependency here that you may want to mock that out as well. Okay. So anyway, that should be a good start. If you were going to, let's say, create another method here that tests to see if that value, its key were the person key, right? We could copy this method here, and you can see that we would say, for example, test save user is person key or something like that. Okay, and then we are going to have this same arrange business, but our cert is going to be different, right? So what we would want to do here is refactor all of this arrange stuff into, we can, for example, do setup, and then func teardown super dot teardown. Okay, so we'd want to move this code into setup and teardown. Sorry, this is override. Okay. So for instance, so you'd need to, for instance, make these the system under test, I guess, is the person manager. This probably. Anyway, you get the idea. You would have to refactor. Obviously, you're repeating a bunch of code here. You would have to refactor this into either setup or teardown. So, okay, I'm not going to do that because we need to move on. Okay, so the last one here is going to be a stub. So this is the Bill computer test. So notice how I basically have a test class for each of the classes in question here. So I don't actually have a Bill class, a Bill test, but anyway, you could create one. But you can see that the Bill computer, which is going to compute the bill, has its own test class, and that's this class here. So you can see that I've actually gone ahead and made a Bill computer stub object, and it's a class. And notice how I've just stuck it right out in this test file here. So I'm in the comment, I say using a stub of Bill computer test to see if the total owing is correctly updated on the person object. Okay, so let's do that. Arrange, act, and assert. Okay, so let's go ahead and look where we want the person object to be updated. So let's look at the person object. Oh, and that's this method right here. So actually this is it's this method right here, this total owing method. So what we total owing, you can see it takes an array of bills, and it takes a bill computer object here. So in this case, I am subclassing Bill Computer as the stub. So I can pass Bill Computer into this method, and it's calling the compute method and setting total owing on the system under test. Okay, so this basically this dependency Bill Computer talks, essentially its job is to do something and then set, and then this function actually sets the return value of that to this property here. Okay, so I'm going to pass the dependency in, which is going to be a stub, and it is going to implement compute, which is the method on this Bill Computer. It's overriding, you can see it overrides compute, and it's just returning a value of 100. So it's just a dummy value that I'm going to test to make sure that total owing got set to that value. Okay, so how do I arrange?
Person and create two classes. Person.
Okay, so person. So just like that. Okay, what else? So I want to call total owing on person. So what other dependencies do I have here?
Bill. You need a bill, and you also need a bill computer.
Sorry, bills. Yeah. So I need a bills. That's going to be an array of bills. So I'm just going to create a bill here. So the initializer is amount. Let's see if I can get it to come up. It doesn't come up. 20.0. Oops. Don't know why that's doing that. Okay, so I've just added one bill there, just as a dummy object. So bills. So I also need a bill computer. So that is going to be our stub. Bill computer stub. Okay. So now I've got everything I need, right? So I can act. So I'm going to do SUT dot total owing, pass in the bills. with the stub. Okay. So now this is where the fact that this is a stub means that I'm asking the system under test for, I'm asserting against the system under test rather than the mock where I was asserting on the mock object, right? So it's just like I'm passing in some kind of like dummy data or something as part of this object. And then I'm asserting against the system under test, not the mock. So XCT assert. Oh, and I also need be expected equals. So I'll just set it to 0. So that should be actually a double 0. So I'll just make that just to make it explicit. So expected equals so system under test dot total owing.
Shouldn't be stub. Let's check that out.
No, because the so I'm passing the dummy object in here, right? That has compute on it, which just returns 100. It's ignoring this parameter. It's just returning 100, and it sets it under system under test total owing. Does that make sense?
Yeah.
Okay.
I thought this was the other test here. That's why. I thought this was a mock, so you don't check the stub again.
No, this is a stub, so we're actually just passing that in and then testing the system under test. So, okay, so this should be 100, right? That's what that error says. All right, so we're past. So that is a little bit of a contrived example. Obviously, these are contrived examples. I'm trying to keep the code simple of a mock and a stub. So getting the mock object, we expect that fake object to see some values changed on it. In the case of the stub, that is make some change on the system under test, and we're going to inspect the system under test in that case.